So in the last video we have stopped to the problem, right? Now that you all have a notebook, calculator and pen. So again we'll just draw the figure for the problem. A three-hinged parabolic arch hinged at the supports and at the crown. Okay, so this first will give you what? It's a three-hinged parabolic arch. So we just go for drawing a three-hinged parabolic arch. Okay, and it is hinged at the support and at the crown. Okay, fine. We have the support, one support over here, then other support over here. Just name it as A, then you have B, then you have C, the other hinge. Okay, has a span of 24 meter. From that you can draw this, that is, it is of 24 meter. Then it's a central rise of 4 meter. Okay, central rise of 4 meter. Another thing also you can do along with this is it's given span as 24 meters. So from the equations of this you would have studied that span is given by L, right? The notation of span is L. So you can write it as L equal to 24 meter. Now another thing you have got it as rise as H equal to 4 meter, right? Okay. Now rest of the question. It carries a concentrated load of 50 kilonewton at 18 meter from the left support. Okay, so this is your left support, this is your left support, and this is your right support. So it carries a concentrated load of 50 kilonewton, right, at 18 meter from the left support. So from left support you have 18 meters. This span is 24 meter. So from here to here it will be, that is, from here to here itself it will be 12 meters, right? So where will be 18? Again it will be on this side, right? Here you have 50 kilonewton. It is given, that is 50 kilonewton at a distance of 18 meters. Clear? So write it as 18 meter, 50 kilonewton. Normally for arch loading type we just draw like this, okay? Just a line and note it. Then a UDL of 30 kilonewton per meter over the left half. You have the left half as this side, right? UDL of, draw this UDL 30 kilonewton per meter. Kilonewton per meter. Clear? Determine, okay. With this, your figure is complete as per the question. Clear? Now that you, this much data is given, then what you need to determine support reactions. Okay, you need to find, what all you need to find? First one, support reactions. Okay, you need to find support reactions. Okay, now what is your notation for support reaction? What you need to do? You need to mark the support reactions. Okay, here you see, what is this one? VA. Then it's an arch, you have an internal one, that is H. Same way over here, what you have? H. And what do you have over here? VB. Clear? So these are the support reactions. So what you need to find out? you need to find out VA, you need to find out VB, then you need to find out H. Clear? This is what you mean by support reactions. Now, what is the second part of your question? What do you need to determine? You need to determine N and radial shear at 6 meter from the left support. What is N? N is normal thrust. So you have to determine N and radial shear at 6 meter from left support. Okay, so this is the other thing which you need to determine and complete it. Now what else? You need to find one more thing. Third, you need to find the moment at 6 meter from the left support. It's bending moment at 6 meter from left support. Clear? With this much data, you are ready to do the problem. Okay. So now we enter into the problem. So to determine VA, what are we going to do? We are going to take moment about B. Okay. Once you take moment about B, that is sigma MB equal to 0, we can calculate VA. Okay. Now, while taking moment about B equal to 0 or by taking moment about A equal to 0, please note the sign convention. So, if it is clockwise, take it as positive. Clockwise, take it as positive. If it is anti-clockwise, take it as negative. Clear? Negative. Then another important thing is this sign convention should be followed throughout the problem. Okay. Now we are going to take moment about B. What all you have? VA into 24, right? And what is the direction of VA? See, this is VA, right? VA into 24. It goes in a clockwise direction. So you have positive minus 30. It is a uniformly distributed load. So it should be multiplied by the span, that is 12, multiplied by the distance to B. Now please note here, that is the uniformly distributed load will be acting at the center, right? This, that is 30 into 12 will be acting at the center of 12, right? It is over the left span. So center of 12 is 6. So from here to B, it is 6 plus 12 and it is 18, right? So you have the distance to UDL as into 18, right? Then minus one more load you are having 50. So 50 into 6 equal to 0. How you got 6? It is already given in the question that 50 is at a distance of 18 meter from left hand side. So 24 minus 18 will give you 6. Now use your calculators and check whether you are getting VA as 282.5 kilonewton. Okay, clear? Okay. Now you need to go for VB. Now another easy method, that is instead of taking moment about A, you can write as VA plus VB equal to, what is VA plus VB? UDL is 30 into 12 plus 50. Okay. Now calculate your VB. Use your calculators, get the answer as 127.5 kilonewton. Clear? Okay. Next, we go for calculating H, right? It's a horizontal thrust in the arch. And to determine this H, you need to take moment about C. So another important thing which you need to note is while you're taking moment about C, either you should take the left hand side of the arch or you should take the right hand side of the arch, not the two sides together. Okay. Now if you go for the right hand side, what all you will have? VB into 12, that it carries with a negative sign. So VB into 12 plus H into 4 plus 50 into 6 equal to 0. This is what you will get. You can substitute and get your answer for H. Okay. H equal to 307.5. Check with your answers whether you are getting this. So we have completed with H. Clear? Now, we were asked to determine the support reactions. Okay, we determined VA, VB and H. Now, your question is, we need to calculate normal thrust N and radial shear Q, right? And it is given both you require to determine at 6 meters, okay, from left support. So, what you need to do is, we have the equation of both, right? We have the equation for normal shear as V sin theta plus H cos theta, right? Now what you do is, you do a thing, just name this as, you need to determine at 6 meters, right? Let this be D, just a point D, okay? So you can write this as ND and VD HD, because I don't want you to confuse between those. Now see, if you're going to determine this normal thrust, so many things are there you need to find. What is VD? What is theta? What is HD? What is theta again? So these quantities, if you know, you can easily substitute. So we go for the searching, or we are going to find out these quantities. Now first of all, theta came into scene, right? Okay, now for determining theta, what I have told you, it's a parabola, right? What's the equation of a parabola? 4hx by L square into L minus x. Okay. Now this is y. Now your dy by dx is tan theta, right? And then when y is this one, you have dy by dx as 4h by, sorry, it's capital L, okay, don't confuse, h by L square into L minus 2x, right? Substitute it, determine tan theta, and you get theta as 18.43 degrees. Okay. Now we are done with theta. Next, what we need to do, what is VD and what is HD. Now what is VD? That is vertical shear at D on the left hand side. What is D? At 6 meters. What are included in it for VD? What are forces you will have on the left hand side? You have VA, and at 6 meters what you have? You have the UDL. So minus 30 into 6. This is VD. What's the answer? You have it as 102.5 kilonewton. Next, in the same way for HD. On left hand side up to 6 meter, what do you have for HD? Same thing, 307.5. Nothing else is there, right? So we have your VD and HD. So you get your answer for normal thrust as 324.13 kilonewton and radial shear as 0.028 kilonewton. Substitute in the equation for radial shear, that is V cos theta minus H sin theta, and get the answer. Next, what you need to do,